Translate the following phrases into algebraic expressions. We don't need to solve these. We just need to translate them into an expression. So they're not equations yet. So we're not worried about equal parts. Some terms or vocabulary for this sum is the answer to an addition problem. Difference. I need more space, dang it. Difference is subtraction. Yeah, I guess that's all I'm seeing right here. Product, there we go, thank you. Product is multiplication. Quotient is a division problem. Now these are pretty straightforward. If it tells us we have the sum of something, then we add, or if it's the quotient, then we divide. Increase would be addition as well, because we're going to take a number and increase it. Again, that's not too bad. What we get, where we find trouble is where we see this less than stuff. Less than. This is where most of my students really struggle. Because if I say that, let's say that we had $5 less than $12. How many dollars do you have? $7. The problem is when we say this out loud, we do 5 minus 7. 12, sorry. I said 12 before, right? Well, this would give us negative 7. But you don't have negative $7, you have 7. So the order here is just switched. You've got to start with the 12 and then subtract the 5. See that right there? So you have to be extremely careful, mostly when you see this less than stuff.
So when you see the less than.
Let's start with number 1, the sum. Well, sum is addition of 3 and a number. So I got 3 plus some number. I always use x. You can use whatever letter you want. If for some reason you like the letter, just stay away from the letter O. That's a bad letter, actually. Or lowercase l sometimes. All right, the difference of two numbers. So difference is subtraction, and we've got one number, and we've got two numbers. Now again, it didn't tell us what those numbers were. You didn't have to use x and y. Some people like to use a and b. It doesn't matter. The product, so this is multiplication of 8, and this goes just directly in order. The product of 8 and a number. Of course, if you wrote that as 8x, that would be okay as well. It's the same thing. Quotient is division. The quotient, again, this is just an order of a number and 10. But once again, the format doesn't matter to me. X over 10 is the same thing. This one has the word less, but it's not less than, okay? So this one is just in order. We have the number and then less 7, so we're just going to take 7 off of that right there. Now, if this was a number less than 7, we would have switched those two. 7 minus x. That's kind of unfortunate, by the way, because it's such a small difference. So we have to we may have to take some time to really double check how we're thinking about these. 7 less than a number. So we have the number, and then it's 7 less than that. Whatever the number is. So again, the order changes, and hopefully you guys notice right now that it really only changed on this one. Well, twice a number. So you have two sets of an x. All right, 9 comes in two different ways for me. And I don't think the homework's picky like this either. So 10 more than twice a number. Technically, we would do 2 times the number, or twice the number, and then take 10 more of that. But because this is addition, and this is the only why it doesn't matter the order, you can write this as 10 plus 2x. These are going to have the same value. So it's only when we have less than. More than is not going to make any difference. Number 10, 3 times a number increased by 8. That one's direct. 3 times a number, and we'll increase that by 8. Done. Now 11 is 3 times the sum of a number and 15. So we got to find the sum of a number and 15 first, and then we'll take 3 of those. See the difference there? So this is how distribution is incorporated into these types of word problems. 12 is going to work the same way. Twice the difference, that's subtraction of 10 and a number, but it's twice that. So whatever we get from 10, the difference of 10 and a number, we'll take 2 of those. So these are the expressions here. All right, 13. Jacob is 6 inches taller than Grant. If we let G represent Grant's height, write an algebraic expression for Jacob's height. It's just an expression. So G is Grant. And in relation to Grant, how does Jacob relate? He is 6 inches taller. So we're going to take Grant's height and just add 6 inches. That's it. Number 14, Mike and Mark drove 240 miles on a trip. Mike drove the first X miles. Mark drove the rest of the way. Write an algebraic expression for how many miles Mark drove. Well, we're going to drive 240 miles, right? And then Mike drives X miles, so we're going to take off of that X, and that would be Mike's distance driven. Well, it said Mark, dang it, sorry, Mark drove the rest of the way, so whatever was left after that, Mark drove, that's it. Number 15, Brianne is 2 years less than twice Kyle's age. This one's a little tricky. If K represents Kyle's age, write an algebraic expression for Brianne's age. So Brianne is 2 years, but it's 2 years less than 2 times Kyle's age. Oh, they wanted a K for Kyle. There we go. So if we double Kyle's age, then we take 2 years off of that, then we will know Brianne's age. All right, and 16, the length of a rectangle. Let's take a look at that. The length of a rectangle is 3 feet less than the width. So the length is 3 feet less than the width. Express the length of the rectangle in terms of the width. There it is. W minus 3. It didn't tell us to use W, so again, you could have used X or some other letter. W looks good, though. Now we're going to translate into equations. So, the main difference we're looking for here, still going to look for that less than stuff, quotient, sum, product, and difference. But now we're looking for the word is. Wherever we find is, that's very good. We're going to replace with equals. So a number added to 13 is 28. So the is, again, gives us our equals. And then we got a number added to 13. So technically this would be 13 plus the number. Not that it really matters because it's addition. And then we've got the 28. All right, it does want us to solve, so we just want to get rid of the 13 so we have just the x. So we got to subtract 13 from both sides. So in this case, it looks like 15. And sure enough, 13 plus 15 is 28, so that's good. The sum of 7, 9, and a number is 40. Find the number. Okay. Well, this is a sum, so we're just going to add all these together. The sum of 7, 9, and a number is, so there's our equal sign, 40. And we can combine 7 and 9 to get 16. Plus x equals 40. But again, we just want the x. So over here we'll subtract 16. But if I do it to one side, I must do it to the other side. X equals 24. The sum of 5 and 6 times a number is negative 25. So the sum of 5 and 6 times the number is negative 25. That's pretty good. To solve this, we'll subtract 5 from both sides first. And we got 6x equals negative 30. To solve this, we'll just divide both sides by 6. And we get x equals negative 5. Six times the sum of 5 and a number. So 6 times the sum, so we will find the sum of 5 and a number, is negative 24. So to solve this one, we'll distribute the 6. So I got 30 plus 6x equals negative 24. And then I'll subtract 30 so I can get these 6x by themselves. That equals negative 54. So to solve, I'll just divide both sides by 6, and I get x equals negative 9. All right, twice the number subtracted from 60 is 20. So this is that less than stuff. Twice the number is being subtracted from the 60. So we're going to start with 60, and then we're going to subtract twice the number. And that is 20. So that was a little tricky of them. But hopefully that makes sense right there. So we just want the negative 2x by themselves. We'll subtract 60 from both sides. So I got negative 2x equals negative 40 now. If I divide both sides by negative 2, then I get x equals 20. All right, if 6 times the number is increased by 4, so let's write that down. 6 times, oh, what the heck? 6 times the number increased by 4. The result is, so that'll be equal to negative 8. So again, solving this one, we got to get rid of that plus 4. Subtract 4 on both sides. 6x equals negative 12. And dividing by 6 on both sides, x equals negative 2.